What if I told you that the United States once tried to wrap the Earth in nearly 500 million tiny copper needles? Not by accident, not as space junk, but as one of the most secret military experiments of the Cold War. For a brief moment, American scientists believed they could build an artificial sky. It sounds impossible, but it happened. The project sparked international outrage, alarmed astronomers around the world, and forced diplomats to defend an idea so unbelievable that many thought it was science fiction. Yet to the people who approved it, the alternative was far more terrifying. Because in the summer of 1958, one discovery revealed a weakness that could cost America a nuclear war. This is Dark Atlas. The Cold War wasn't only a race to build bigger bombs, it was a race to stay connected. Every bomber in the air, every submarine beneath the sea, every missile waiting underground, depended on receiving a single order at exactly the right moment. If those orders never arrived, the world's most powerful military could become useless within minutes. Then came a shocking discovery. During a series of high-altitude nuclear tests over the Pacific Ocean, American scientists watched as the explosions disrupted the ionosphere, the invisible layer of charged particles that carried long-range radio signals across the planet. For hours, communications became unreliable. To the public, it was just another nuclear test. Inside the Pentagon, it was a nightmare. Military planners realized that in a real nuclear war, a single explosion high above Earth might silence their global communications. And there was another problem. Thousands of miles of undersea cables carried critical military messages between continents. But those cables could be cut. A Soviet submarine, a few explosives, and the connection could disappear forever. For the first time, American defense officials faced an impossible question. What if the cables were destroyed and the sky itself stopped carrying their signals? Some engineers suggested stronger transmitters. Others proposed larger antennas. But inside MIT's Lincoln laboratory, one electrical engineer imagined something no one had ever attempted. Walter E. Morrow didn't want to improve the atmosphere. He wanted to replace it. His proposal was almost unbelievable. Launch hundreds of millions of microscopic copper needles into orbit. Together, they would create an artificial ring around Earth, allowing radio signals to bounce across the globe even if the natural ionosphere failed. To some, it was brilliant. To others, it sounded completely insane. But the most unbelievable part, the United States was actually preparing to build it. The proposal quickly moved beyond MIT. Military officials studied the idea. Scientists argued over it. Some believed Walter Morrow had found the future of global communications. Others believed he had lost his mind. But the Cold War had changed the rules. If this strange idea could keep America connected during a nuclear attack, it deserved a chance. The project received a classified name: Project West Ford. Inside Lincoln Laboratory, engineers faced a problem no one had ever solved. The artificial ring couldn't be made from large antennas. It had to consist of nearly 480 million microscopic copper needles. Each one measured just 78 centimeters long, and was thinner than a human hair. Individually, they were almost meaningless. Together, they could become the largest radio reflector humanity had ever created. But there was another problem. If millions of tiny needles were released into space all at once, they would instantly clump together, making the entire mission useless. The solution sounded almost as strange as the project itself. Engineers embedded every copper needle inside solid naphthalene, the same chemical found in ordinary mothballs. Inside the laboratory, one of America's most advanced military projects carried the unmistakable smell of an old closet. The plan was surprisingly elegant. Once the payload reached orbit, sunlight would slowly evaporate the naphthalene into gas. As it disappeared, the tiny needles would drift apart naturally, spreading into a thin belt around the Earth. On paper, everything worked. Now they had to prove it in space. On October 21st, 1961, an Atlas Agena rocket lifted off from Vandenberg Air Force Base carrying the world's strangest payload. Inside the control room, engineers watched every number, every light, every signal. The rocket reached orbit exactly as planned. For a few moments, it looked like years of work had paid off. Then, something went wrong. The dispenser failed to spin correctly. Instead of scattering into a perfect ring, the copper needles stuck together in useless metallic clumps. The world's most ambitious communication experiment had become thousands of pieces of expensive space junk. For many observers, Project Westford was over. Critics called it a disaster. Astronomers renewed their protests. Even some government officials questioned whether the mission should continue. But the engineers refused to give up. They believed the idea wasn't broken. Only the first attempt was. So while the world mocked the failure, MIT quietly prepared to launch again. The engineers were right. The idea deserved one more chance. On May 9th, 1963, another Atlas Agena rocket climbed into the California sky carrying a redesigned payload. This time, everything worked. As the naphthalene slowly evaporated in the vacuum of space, nearly 480 million copper needles spread into a thin ring almost 3,500 kilometers above Earth. For the first time in history, humanity had deliberately altered the space surrounding its own planet. Now came the moment that mattered most. At MIT's Millstone Hill Station in Massachusetts, engineers aimed a powerful radio signal toward the invisible cloud orbiting overhead. Seconds later, a weak voice returned. The signal had traveled thousands of miles, bounced off the copper ring, and reached its destination. Project Westford had succeeded. But outside the laboratory, not everyone was celebrating. Astronomers warned that humanity was turning space into a dumping ground. Newspapers questioned whether any nation had the right to change the night sky. Inside the United Nations, American diplomats found themselves defending one of the strangest engineering projects ever attempted. They insisted the needles would not remain forever. Sunlight itself would slowly push them out of orbit, allowing most of them to re-enter the atmosphere over the following years. Ironically, while the world argued about Project Westford, technology moved on. In 1962, the communications satellite Telstar had already demonstrated a simpler and far more powerful solution. Instead of bouncing radio waves off hundreds of millions of copper needles, one small satellite could do the job better. Almost overnight, Project Westford became obsolete. The artificial ring was never expanded. The experiment quietly faded into history. Yet its legacy survived. The controversy helped shape international discussions that eventually influenced the 1967 Outer Space Treaty, reinforcing the idea that space should be protected for all nations, not altered without consequence. Today, most of the tiny copper needles have long since fallen back to Earth. A few small clusters are still believed to remain in orbit, silent reminders of one of the Cold War's boldest experiments. History often remembers the rockets that reached the moon, but it almost forgot the day humanity tried to build an artificial sky. Sometimes the strangest ideas are real. And sometimes the greatest Cold War secret wasn't hidden beneath the ocean or buried underground. It was scattered across the darkness above our heads. This is Dark Atlas.